The number pi is a mathematical constant, approximately equal to 3.14159. It is defined in Euclidean geometry as the ratio of a circle's circumference to its diameter, and also has various equivalent definitions. The number appears in many formulas in all areas of mathematics and physics. The earliest known use of the Greek letter pi to represent the ratio of a circle's circumference to its diameter was by Welsh mathematician William Jones in 1706. It is also referred to as Archimedes' constant. Being an irrational number, pi cannot be expressed as a common fraction, although fractions such as 22/7 are commonly used to approximate it. Equivalently, its decimal representation never ends and never settles into a permanently repeating pattern. Its decimal digits appear to be randomly distributed, and are conjectured to satisfy a specific kind of statistical randomness. It is known that pi is a transcendental number. It is not the root of any polynomial with rational coefficients. The transcendence of pi implies that it is impossible to solve the ancient challenge of squaring the circle with a compass and straightedge. Ancient civilizations, including the Egyptians and Babylonians, required fairly accurate approximations of pi for practical computations. Around 250 BC, the Greek mathematician Archimedes created an algorithm to approximate pi with arbitrary accuracy. In the 5th century AD, Chinese mathematics approximated pi to 7 digits, while Indian mathematics made a 5-digit approximation, both using geometrical techniques. The first exact formula for pi, based on infinite series, was discovered a millennium later, when in the 14th century the Madhava-Leibniz series was discovered in Indian mathematics. The invention of calculus soon led to the calculation of hundreds of digits of pi, enough for all practical scientific computations. Nevertheless, in the 20th and 21st centuries, mathematicians and computer scientists have pursued new approaches that, when combined with increasing computational power, extended the decimal representation of pi to many trillions of digits. The primary motivation for these computations is as a test case to develop efficient algorithms to calculate numeric series, as well as the quest to break records. The extensive calculations involved have also been used to test supercomputers and high-precision multiplication algorithms. Because its most elementary definition relates to the circle, pi is found in many formulae in trigonometry and geometry, especially those concerning circles, ellipses, and spheres. In more modern mathematical analysis, the number is instead defined using the spectral properties of the real number system as an eigenvalue or a period, without any reference to geometry. It appears therefore in areas of mathematics and sciences having little to do with geometry of circles, such as number theory and statistics, as well as in almost all areas of physics. The ubiquity of pi makes it one of the most widely known mathematical constants, both inside and outside the scientific community. Several books devoted to pi have been published, and record-setting calculations of the digits of pi often result in news headlines. The symbol used by mathematicians to represent the ratio of a circle's circumference to its diameter is the lowercase Greek letter pi, sometimes spelled out as pi, and derived from the first letter of the Greek word perimetros, meaning circumference. In English, pi is pronounced as pi. In mathematical use, the lowercase letter pi is distinguished from its capitalized and enlarged counterpart, which denotes a product of a sequence, analogous to how denotes summation. The choice of the symbol pi is discussed in the section Adaptation of the symbol pi. Pi is commonly defined as the ratio of a circle's circumference c to its diameter d. The ratio c/d is constant, regardless of the circle's size. For example, if a circle has twice the diameter of another circle, it will also have twice the circumference, preserving the ratio c/d. This definition of pi implicitly makes use of flat geometry, although the notion of a circle can be extended to any curved geometry. These new circles will no longer satisfy the formula pi equals c/d. Here, the circumference of a circle is the arc length around the perimeter of the circle. a quantity which can be formally defined independently of geometry using limits. A concept in calculus. For example, one may directly compute the arc length of the top half of the unit circle, given in Cartesian coordinates by the equation x2 plus y2 equals 1, as the integral. An integral such as this was adopted as the definition of pi by Carl Weierstrass, who defined it directly as an integral in 1841. Integration is no longer commonly used in a first analytical definition because, as Remert 2012 explains, differential calculus typically precedes integral calculus in the university curriculum, so it is desirable to have a definition of pi that does not rely on the latter. Oh,